Hello and welcome to our lesson on the unit circle. So what I have in front of you here is a picture of what we call the unit circle. It may be something that you've seen before, it may not, maybe something that looks kind of intimidating, which is understandable at this point, but what we're going to look at today is where this thing comes from. Where do all these numbers and all these radical 3's divided by 2, all the angles in there, where is all this coming from? How is this unit circle built? And then what is the purpose of it? What can we do with it once it's built? So we're going to sort of do a baseline build of it today, and then we're going to add on over the next few topics, but for now, just like when we talked about angles, when we, are asked to draw, let's say, a 45-degree angle, there are multiple ways that we could do this, but if we put it in standard position, there's a guarantee that we all draw the same 45-degree angle. It's kind of similar with the circle. If I said draw a circle, there's no guarantee in what size or where the circle is going to be. If we put it in like an angle in standard position, if we put it on a graph, then we can come up with the same angle if we know that the radius length is a certain amount. So the unit circle is just a circle that's graphed. So if we put it on a coordinate plane and we center the circle about the origin, it's going to be called a unit circle when the radius has a length that is exactly 1 unit. So the unit circle is graphed on a coordinate plane. That just means we're graphing it on an x and y axis with a center at the origin and a radius of exactly 1 unit. So this is what a circle centered around the origin would look like. Again, here's our origin, the center of our circle at 0, 0. And if we have a radius of 1, so if our radius length is 1, then the coordinates at this point here would be 0, 1. Not moving along the x, just going on along the y. Or let's say the coordinates at this endpoint here. Again, that's a radius length of 1, so if this is 1 and this is 1, then this time we're going to go over 1, but we're not going up, so the coordinates there would be 1, 0. Or if we go this direction, then the coordinates here, again, radius length of 1 would make this negative 1, 0. And then if we went, need one more color down, radius length of 1, then the coordinates here would be 0 and then negative 1. Okay, so that's a unit circle. A unit circle is just a circle that's put on a graph, the center of that circle being at the origin, and we're going to call it a unit circle because it has a 1 unit radius length. Okay, so there it is. Now, we're going to add to this. Eventually, it's going to start looking like what I showed you in the beginning. But where do the things that we add come from? And what is this used for? Well, once it's all built, then the unit circle is basically used as a reference sheet. And what it allows us to do is really quickly identify exact values for the sine and the cosine of what I'm going to call special angles, the same special angles that we saw in our special right triangles. So these special right triangles are what build the unit circle, and when I say these triangles, what I mean specifically is the patterns. So we're going to build the unit circle using the patterns that exist in the special right triangles. So in our 45, 45, 90, remember that if these two angles are the same, that these two side lengths are the same, and to get the length of the hypotenuse, we're just multiplying that leg length, that side length, by a radical 2. And then in our 30, 60, 90, across from our smallest angle, we call that side x. If whatever length that side is, we double it to get the hypotenuse, and we multiply it by a radical 3 to get the longer leg length. Okay, so we've talked about those before. Now let's see how this connects to the unit circle. So let's look at, again, a special right triangle here. In this case, these markings tell us these angles are equal. So this is a 45, 45, 90 triangle that has a hypotenuse of 1. So we should be able to find the missing sides using our patterns, right? We said in our 45, 45, 90 that we're going to multiply by a radical 2 to get our hypotenuse if we know the leg length. Well, now we're going to go in reverse. Since we know the hypotenuse is 1, we would divide a radical 2 to figure out the leg length. So if I took 1 and divided it by radical 2, then that leg has a length of 1 divided by radical 2. Technically, to be proper, we're going to rationalize this. If we multiply by radical 2, then we're going to say this leg length is 1 radical 2 divided by 2. And this one has got to be the same, so this would be a radical 2 divided by 2 here as well. Alright, so now we have all the sides of this triangle. If I asked you to find the cosine for the 45-degree angle, and let's just pick one. So let's say I wanted the cosine of this 45-degree angle. I know that the cosine is a ratio of the adjacent side over the hypotenuse. So in this case, it would be radical 2 over 2 divided by 1. But dividing by 1 does nothing to our fraction, so it doesn't change our value, which means we can simplify this and say that the cosine of 45 is just going to be radical 2 over 2. And then what about the sine for 45? So the sine for 45 is a ratio of the opposite side, that's over here, over the hypotenuse. Well, that opposite side has the same measurement as the adjacent side, and again, the hypotenuse is 1. So if I divide by 1, I'm not going to change anything, which means the sine of my 45-degree angle is also going to be radical 2 over 2. Alright, so hopefully so far so good. This is review information. We've got our 45, 45, 90. We found the missing sides using our patterns, and then used cosine and sine ratios to find the cosine and sine of those 45-degree angles. Now, how does this connect to the unit circle? What we're going to do is take this 45, 45, 90 triangle, and this is a unit circle that's pictured here, okay? So this is I tried to outline that, a unit circle, which means we're looking at a radius length of 1, okay? Now let's take our 45, 45, 90 triangle and actually put it into, just translate it over into this unit circle. So I'm going to put that triangle here. Same exact triangle. So we had a hypotenuse of 1, right? That's this length here is 1. And this side was a radical 2 over 2. And then this side is a radical 2 over 2. And here's our 90-degree angle. So same triangle, just translated over. Now what happens when I translate this over is this corner of the triangle intersects the unit circle. Okay, and that intersection of the unit circle, that's a coordinate in our coordinate plane here. What are the coordinates at that point would be my question to you. Well, when I'm looking for the x-coordinate, I want to know how far along the x-axis did I have to travel to go there, and the y-coordinate is how far did I have to travel on the y-axis to go there. So I'm going over radical 2 over 2 units and up radical 2 over 2 units to get there, which means this coordinate, where this 45, 45, 90 triangle intersects the unit circle, is radical 2 over 2 and radical 2 over 2. Okay, so maybe you're thinking to yourself, so what? Well, now that I know that coordinate on the unit circle, not only do I just have a coordinate, what I have, remember, is the sine and the cosine for 45 degrees. So remember, this is a 45-degree angle in here. If I asked you what the cosine of 45 degrees is, you don't have to, use your patterns or figure anything out, go to a calculator, because we just determined over here that the cosine of 45 degrees was radical 2 over 2, and I can see that here. The cosine of 45 degrees is radical 2 over 2. And the sine of 45 degrees was radical 2 over 2, and I can see that here. Okay, the sine of my 45 degrees is radical 2 over 2. That's the distance along the y, right? That was my opposite side. And the distance along the x, right? That was my adjacent side. So when I'm looking at these coordinates, what I'm seeing are the values for the cosine and sine of my 45-degree angle. Okay, and if that's not quite registering yet, that's okay. But what we're going to do now is take this same triangle and we're going to reflect it around the quadrants. So if I took this same triangle and I just reflected it into quadrant 2. So now let me draw my triangle here. Same triangle, just now in the other quadrant. Still a 45, 45, 90. Okay, which means the coordinates here should be the same because I'm still going over radical 2 over 2 and up radical 2 over 2 to get there. So these coordinates are radical 2 over 2 and radical 2 over 2. But because we're in quadrant 2 now, our x's are negative. So this is going to be a negative x value. I'd have to go left radical 2 over 2 and up radical 2 over 2. And so now what I have, again, not just coordinates where that triangle intersects the unit circle. What I have are values for the sine and cosine of an angle. But it's not a 45-degree angle this time. What kind of angle are we looking at? Well, the reference angle is 45 degrees, but the actual angle that we're looking at is, now remember, we start here on the positive x-axis and we land here. That would be a 135-degree angle. So if I said, what is the cosine for 135 degrees? I can see right there it's going to be a negative radical 2 over 2. And if I said, what is the sine for 135 degrees? It's going to be right there, positive radical 2 over 2. Okay? And then I'm going to take this into the next, reflect it into quadrant 3. So if I reflected this triangle into quadrant 3, again, same exact triangle, still a 45, 45, 90. 45, 45, 90, which means the coordinates here are the same. I have to go over radical 2 over 2 and down radical 2 over 2 to get there. So the same coordinates, but again, we're in quadrant 3. I had to go left and I had to go down, so now those values are both negative. And those values, again, are going to represent the sine and the cosine, or the cosine then the sine, for an angle. The question is now, what is the angle? Well, this angle still has a reference angle of, I need a new color highlighter, but I've used them all up. So we're still looking at a reference angle of 45 degrees, but total, so the angle starts here and goes here. So we'd be looking at 180 degrees plus another 45. So we said this one was 135. This one would be 180 plus another 45, so this is a 225 degree angle here. So what this is helping us see, again, is the sine and cosine for 225 degree angle. If I said, what is the cosine for 225? It's negative radical 2 over 2. And in fact, if you put that in your calculator, you're going to get a decimal approximation for negative radical 2 over 2. Or if I said, what is the sine for 225? Here it is, negative radical 2 over 2. Okay? And then we're going to go one more time into quadrant 4. So into quadrant 4, again, same exact triangle, which means the same exact coordinates. But we're in quadrant 4, so this is a positive x and just a negative y. And now what is the measure of the angle that we're looking at? So again, we have here, go to my highlighter, a 45 degree reference angle for an angle that starts here and stops here. So not the full 360, but 45 degrees short of that full 360. So 360 minus that 45 is 315. So this is a 315 degree angle here. And again, what I can see with these coordinates is that the cosine for that 315 degree angle is radical 2 over 2, and the sine for that 315 degree angle is negative radical 2 over 2. Okay, so that one triangle gave us all of this information. And once we have it all in the unit circle, again, we're just going to use it as a reference sheet. Now I can tell right away what the sine and cosine are for 4 different angles in my unit circle. And notice what I was kind of saying all along here is that all of the angles with a 45 degree reference angle. So that was the 45 that we started with, and then the 135 in quadrant 2, the 225 in quadrant 3, and the 315 in quadrant 4. All of those have the same coordinates. The only thing is that the signs vary because we're varying in our quadrants. So all angles with 45 degree reference angles intersect the unit circle at the same place. So that's a 45 degree angle, a 135 degree angle, a 225 degree angle, and a 315 degree angle. They all intersect the unit circle at coordinates radical 2 over 2 and radical 2 over 2. Okay, all of those are sines and cosines for those angles. The only thing that will vary is the positives and the negatives. Okay, let's do it again. Sorry if I'm breathing loud into the mic here. We're going to look next at a 30, 60, 90, and I'm going to focus on the 30 degree angle for a second. So again, we have a special triangle here with a hypotenuse of 1. Let me go back to our rule. If we have a 30, 60, 90, this time we're starting with a hypotenuse of 1, so we have to work backwards to figure out the other lengths. So instead of multiplying by 2 to go this way, we're going to divide by 2 to go this way. And then once I have the leg length here, the shorter leg length, I'm going to multiply by radical 3 to get that longer one. So now I can undo my mess on this paper. How many times did I don't know. Okay. And actually, this doesn't need to be here either. So let's go back to our triangle, our 30, 60, 90 here. Right, if this is a hypotenuse length of 1, I'm going to divide that by 2 to say this shorter leg length should be a half. And then the longer one, we take that shorter length and multiply it by a radical 3. So if I multiply 1/2 by a radical 3, technically that's radical 3 over 1, what we end up with is a radical 3 over 2. Now, just like we did before, if I said, what is the cosine for 30 degrees? So here's my 30-degree angle. If I said, what's the cosine? It's a ratio of the adjacent side over the hypotenuse. So the adjacent side, which is radical 3 over 2, divided by a hypotenuse of 1 is not going to change it. So the cosine of 30 is radical 3 over 2. And then if I said, what's the sine? Well, it's a ratio of my opposite side to my hypotenuse. So 1/2 divided by 1, again, that's just going to be a half. And you can see where we're going to go. If I translate this triangle to my unit circle, same exact triangle. Okay, again, a hypotenuse of 1 is a radius of 1 in that unit circle. I'm going over radical 3 over 2 units here, and I'm going up 1/2 of a unit here, which means the coordinate where this triangle intersects the unit circle is radical 3 over 2 and 1/2. Okay, and what that coordinate is showing me, again, is the sine and cosine for my 30-degree angle. So if I said, what is the cosine for 30 degrees? It shows up right here in the x value of that coordinate. And if I said, what is the sine for 30 degrees? It shows up right here in that y coordinate. So again, there's my 30-degree angle. Now I know I can reflect this around. So if I take this into, oops, that was terrible. If I take this into quadrant 2, same triangle just reflected. Okay, same triangle, and I should have put this here, just reflected, means we have the same coordinates here, radical 3 over 2 and 1/2, but because we're in quadrant 2, the x value is going to be negative. What's the angle, though, that we're looking at this time? So we do have a 30-degree reference angle here, and the 30-degree reference angle here is just the 30-degree angle that we started with. But now, if we start here and we land here, then the angle that we're looking at is the 180 minus that 30. So this is actually going to be a 150-degree angle. So now if I said, what is the cosine for 150? I know it's negative radical 3 over 2. And if I said, what is the sine for 150? Right there, it's going to be a half. Okay, and now let's take this into the next quadrant. So right here, reflect that triangle over. So we have the same reference angle, but my total angle starts here and ends here is now 180 plus 30. So now we're looking at 180 plus 30, which is 210 degrees. So 210 degrees intersects the unit circle at the same coordinates, radical 3 over 2 and 1/2. But now we're in quadrant 3, so both are negative. So what is the cosine for 210? Negative radical 3 over 2. What is the sine for 210? Oops, that's my eraser, and I meant my highlighter, is negative 1/2. And then one more time, and I'm going to have to move this. Take this and then reflect it over to quadrant 4. Make a 30-degree reference angle here. Same triangle, same coordinates. Radical 3 over 2, 1/2. But now in quadrant 4, the y value is negative. And the angle we're looking at, so starting here but landing here. Okay, we're again looking at a 30-degree reference angle. But the total angle, maybe you're having a hard time visualizing, starts here and ends here. So it's going to be 360 minus that 30-degree reference angle. So what we're looking at is a 330-degree angle. So now I can see if I wanted to know the cosine for 330 degrees, there it is, radical 3 over 2. And if I wanted to know the sine for 330 degrees, there it is, negative 1/2. So all angles that have a 30-degree reference angle, they intersect the unit circle at the same coordinates, radical 3 over 2 and 1/2. The only things that will change will be the signs because the quadrants, the signs are different in different quadrants. So if we're looking at a 30-degree angle, or a 150-degree angle, or a 210-degree angle, or a 330-degree angle, all of those angles will have the same values for sine and cosine, except for, again, positives versus negatives may vary. Okay, and then one more round of this with, again, the 30, 60, 90, but the focus on the 60. So this is our 30-degree angle here, which means take the 1 divided by 2. That means the 1/2 is now here. And it means that the 1/2 times the radical 3, which is radical 3 over 2, ends up here. So now, if my focus was the 60-degree angle, the cosine becomes the adjacent over the hypotenuse becomes 1/2. So the cosine for 60 is 1/2. And then the sine becomes radical 3 over 2. So these two are just going to flip. So when I take this triangle to the unit circle, if I draw in my 60-degree angle from my 30, 60, 90 triangle, right, this is my 60-degree angle in here. It intersects the unit circle at coordinates, remember this was 1/2 and this was radical 3 over 2. So it's going to be 1/2 and radical 3 over 2. And what that's showing me again is the exact values for the sine and the cosine of 60 degrees. So again, what is the cosine for 60? It's right here, it's 1/2. And what is the sine for 60? It's right here, radical 3 over 2. And then we take that into the next quadrant. If I reflect this over, same triangle, same coordinates, 1/2, radical 3 over 2. But now our x is negative. Now what is the measure of the angle this time? Again, the angle is going to have a 60-degree reference angle. Let's put 60 degrees in here. But the angle we're looking at, again, starts here and stops here. So 60-degree reference angle, 180 minus that 60-degree reference angle is 120 degrees. So this is a 120-degree angle here. And now I can see that the cosine for 120 is negative 1/2, and that the sine for 120 is going to be radical 3 over 2. And then if I take this and reflect it into quadrant 3, then the angle I'm looking at this time, again starting here and ending here with our 60-degree reference angle, so that's going to be 180 plus that 60, so the total angle would be 240 degrees here. It's going to intersect at the same spot, or the same coordinates, 1/2 and radical 3 over 2. But in quadrant 4, they're both negative. So the cosine for 240 is negative 1/2, and the sine for 240 is negative 3/2. And one more time. Oh, and I shouldn't have highlighted. Let me just oh, I don't want to undo. Okay, sorry. Give me just a second. Boom, boom. Oops. I want to get rid of the highlight because, there we go. I have to draw another angle in there. So now I have to put, that's my highlighter, put some information back in. I'm sorry, just give me a second. This was 1/2, radical 3 over 2, both negative. And yellow and pink. Okay, so last one. Taking this into and reflecting it into quadrant 4. So there's again our 60-degree reference angle. What is the total angle that we're looking at if we start here and now land here? So again, it's a 60-degree reference angle. But that's a full circle minus that 60 degrees. So 360 minus 60 means the angle that we're looking at is 300 degrees. So this was 300 degrees here. Oh, and it erased my 240. This is 240 degrees here. So 300 degrees intersects the unit circle at those same coordinates, 1/2 and radical 3 over 2. But in quadrant 4, the y value is going to be negative. So if I said, what is the cosine for 300? It's 1/2. What is the sine for 300? It's negative radical 3 over 2. Okay. Now in that picture that I showed you in the beginning, let me just go back to it for a second. Here's our unit circle. So you can see all these coordinates, how we have similar things happening, right? All the coordinates here, 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 and here. Those are all the angles that have the 30-degree reference angle. All the coordinates that are here, 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 and here. Those are all the angles that have the 45-degree reference angle, and all those coordinates are the same, right? All the coordinates that are here. Those are all the angles that have reference angles of 60 degrees. They're all the same. Okay, the only thing that varies is the signs because of the quadrants, and you can see all the angles that are in there. So the unit circle, again, that we use as a reference to quickly identify sine and cosine of all those special angles is just a culmination of all those special triangles. Okay, so we're going to put it all together, make our own little unit circle here. And let me just fill this last part in because I forgot. All angles with a 60-degree reference angle intersect at 1/2 in radical 3/2. So that was the 60, the 120-degree angle, the 240-degree angle, and the 300-degree angle. Those all intersect at the same coordinates. They have the same value for cosine. They all have the same value for sine. The only thing that's changing is positive versus negative. Alright, so let's put it all together, make our own little unit circle, and we can kind of use this as a reference sheet moving forward. And this will be kind of helpful to do because ultimately you're going to want to have this memorized, which might seem a little intimidating, but let me kind of work through how we do this. So let me start by labeling the angles, okay? Let me label the angles. If I start here and I don't go anywhere, I'm looking at technically a 0-degree angle. And remember, this is a radius of 1. So we said the coordinates here would be 1, 0. So a 0-degree angle intersects the unit circle at the coordinate 1, 0. And then I know if I go up here to 90 degrees, we said that the coordinates here would be 0, 1. And then if I went another 90, I know I'm at 180 degrees, that the coordinates here would be negative 1, 0. And if I go down here to a 270-degree angle, that these coordinates would be 0, negative 1. And those coordinates are going to be just as important as all of the others. We'll come back to that in a second. Now, it's a lot of information going on here. I like to start with the 45s, which is where I started on the front, because in the 45s, remember, we have the equal side lengths, which means the coordinates are the same, so I don't have to remember what goes where. I know those are just going to be radical 2's and radical 2's, or radical 2 over 2's. So let me just highlight all of the angles that have a 45-degree reference angle. And maybe let me back up a little bit. Think about the 3 triangles that we did. We talked about the 30 and focused on the 30 and the 30, 60, 90. Then we focused on the 45, and then we focused on the 60. So that's what we have here. Okay, this is the 30-degree angle. This is the 45-degree angle. And this is the 60-degree angle. And actually, if you see the pattern, what's happening here, the same pattern is going to happen all the way around. So there's a 30-degree difference between these first two. And then there's a 15-degree difference between these little ones here. And again, a 30-degree difference here. That same pattern happens all the way around. It's going to be plus 30, plus 15, plus 15, plus 30. Okay, so all the way around, then I can actually fill in these angles. I think I might have went one too far. So if I added 30 to 90, I know that 30 and 90 is going to be 120. And then add 15 to that to get 135. Add 15 to that to get 150. And then add 30, that takes me to the 180. And then this bigger gap means add 30, so this is going to be 210. Add 15 for these smaller gaps, so that's 225 here. Add 15 again, that's 240. And then if I add 30, there's my 270. And then add 30 again, that's a bigger gap, so plus 30 is going to be 300 here. Add 15, so this is 315. Add 15, so this is 330. And then add 30 again, and we get back to 360, a full rotation. So there's all the angles that are created. Now, which ones of them are the same? So this is what I was going to do a second ago, but I got a little ahead of myself. So here's my 45-degree angle, right? Which other angles have a 45-degree reference angle? Well, definitely directly across from it. It's going to be all the ones that end in 5s. So the 45, the 225, the 135, and the 315. Those are all 4 of the angles that have the 45-degree reference angle, which means all of those coordinates will be the same. The only thing that's going to change is the positives and the negatives. So at 45 degrees, our coordinates were radical 2, radical 2. So now I just can go around here and say, okay, this one's got to be radical 2 over 2, and this one has to be radical 2 over 2. Same thing here, radical 2 over 2, radical 2 over 2. And then one more, radical 2 over 2, and then I'm going to go through and change my signs. So in quadrant 1, everything's positive. In quadrant 2, the x is negative. In quadrant 3, they're both negative. And then in quadrant 4, the y is negative. Boom. A third of the way there. Now let's look at the 30 degree. Okay, which other angles have the 30 degree reference angle? So the 30 degrees away from the x-axis there, 30 degrees away from the x-axis there, 30 degrees away there, and 30 degrees away there. So all those angles have a 30 degree reference angle. All of those intersect the unit circle at the same place. So the coordinates in these, in the 30s, were radical 3 over 2, and then 1/2. And then over here again, radical 3 over 2, and then 1/2. And then I go in over here, radical 3 over 2, 1/2. One more time, radical 3 over 2, and 1/2. And then we're positive, positive, negative, positive, negative, negative, and then positive, negative. Fix the signs. Alright, and then one last one, what happens on the 60? So our 60 degree reference angle here, 60 degree reference angle here, 60 degree reference angle here, 60 degree reference angle there. All of those intersect the unit circle at the same place. And remember, the 60, all that happened was these two flip-flop. So if we flip-flop these coordinates, we're going to be 1/2 and radical 3 over 2. And then again, 1/2, radical 3 over 2. And then again over here, 1/2, radical 3 over 2. And then again here, 1/2 and radical 3 over 2. And then it's positive, positive, negative, positive, negative, negative, and then positive, negative. And now we have our unit circle. Now remember, what in the world is this unit circle telling us? It's telling us the exact values for the cosine and the sine for all of the angles that we've labeled in here, including the ones that are quadrantal. So each of these coordinates, the x value in the coordinate and the y value in the coordinate, is showing us the cosine for our angle and then the sine for our angle, again including the quadrantal angles. So if I said, what is the, let me just change to a color, for 360, if I focused on that, if I said what is the cosine for 360, I know it's that x value. Cosine for 360 is going to be 1. Or if I said what's the sine for 360, it's going to be that y value, which is going to be 0. So every single coordinate on this unit circle shows me the exact value for the cosine and sine of those angles. Mind-blowing. Okay, so let's just try to use it now that we've built it. So if I asked you what are the exact coordinates where the terminal side of the angle intersects the unit circle, we're literally just going to pick coordinates off of this reference sheet. So 30 degrees, I can see 30 degrees right here, this angle, these are the coordinates. So I'm just going to write those coordinates down because that's all it's asking me to do here. So 30 degrees is radical 2, or radical 3 over 2 and 1 over 2. 120 degrees, I can see that. That's this angle right here. So those coordinates are 1/2 and radical 3 over 2. But that 1/2 is negative. Let's not lose that. And then what about negative 45 degrees? Okay, negative 45 degrees. I didn't label any negative angles here, but if positive 45 degrees goes up this much, then negative 45 degrees goes down this much. And so negative 45 is really the same as positive 315. Or we could say that that is the coterminal angle. So a negative 45, this is the same as a positive 315. Those are coterminal. And at 315, those are our coordinates. So we're looking at radical 2 over 2 and negative radical 2 over 2. Okay, negative 210. What is coterminal or the same as negative 210? Well, if I add 360, I'm going to get 150 degrees. So, another way is to look at the picture. Okay, if positive 210 goes halfway and then 1, then negative 210 is going to do the same thing in the direction. It's going to go halfway and then 1. And again, that lands at 150 at the coterminal angle. And there at 150 are our coordinates. So we're going to say this is negative radical 3 over 2 and then 1/2. And then 90 degrees, I can see that one easily right there. Coordinates are 0, 1. Okay, so those are the coordinates, but remember the reason we want to know these coordinates or be able to identify them is because they show us the cosine and sine. So if I said what is the exact value for the cosine of each angle, you're going to do the same thing we did, locate the coordinates, and then for the cosine, all we're going to do is pick out the x value in the coordinate. So the x, not value, xy, x value is the cosine. So what's the exact value for the cosine of 45? So cosine of 45 degrees is going to equal, if I go to my 45-degree angle and pick out the x value, there it is. It's radical 2 over 2. So cosine of 45 is radical 2 over 2. If I said what's the cosine for 180 degrees? Again, I go to 180 degrees, pick out the x value, there it is. Cosine for negative 180, or for 180 degrees is negative 1. If I said what's the cosine for negative 135 degrees? Let me find the coterminal first since I didn't label this on my picture. If I add 360 to 135, can't do that in my head. 360 minus 135 would be 225. So the coterminal angle, the same angle we're looking at, is 225 degrees. So if I go to 225, which again is negative 135, my cosine, my x value is negative radical 2 over 2. So we would say, let me just be consistent with colors here, that the cosine for negative 135 is the same as the cosine for 225. Again, that's that negative radical 2 over 2. And then negative 120, again, coterminal to that, if I add 360, that's going to be 240. So if I go to 240, there's my cosine, negative 1/2. So the cosine for a negative 120 degrees is, again at 240, that's right there, negative 1/2. And then 135, nice positive angle, which I already did. 135, there's my cosine again at negative radical 2 over 2. Cosine of 135 equals negative radical 2 over 2. Alright, and now let's try it again, but this time identifying the exact value for the sine of each of our angles. So if we want the sine, now I want the y value in the coordinate. So let's find the coordinate and just pick out the y value. So 60 degrees, back up here, sorry if the scrolling is giving you a headache, the y coordinate is radical 3 over 2. So we would say that the sine for 60 is exactly radical 3 over 2. And if you put this in your calculator, the sine of 60 degrees, you would get the decimal approximation for radical 3 over 2. Negative 150, that's going to be coterminal to positive 210. Let me just, 360 minus 150, I'm really nervous that my brain is not adding and subtracting. Okay, so 210 degrees. If I go to 210, again, the sine, that's the y value, there it is, negative 1/2. So we're going to say that the sine of negative 150 degrees is, I forgot, back to 210, there it is, negative 1/2. And you see how nice this is to be able to use. Negative 90 degrees, coterminal to that. Add 360 is going to be, what, 270? That's a quadrantal angle. Negative 90 degrees landing at 270. Again, the sine is what we're looking for. That's the y value in that coordinate at 270, and that's going to be a negative 1. So we would say that the sine for negative 90 degrees is a negative 1. And then we're almost there. Negative 300. That is coterminal to 60 degrees. So 60 degrees, if I go there, my sine, radical 3 over 2. So the sine for negative 300 degrees is radical 3 over 2. I can't hold all this information and talk at the same time. Okay, last one. We have the sine for negative 330. Negative 330 is going to be coterminal to positive 30, right? If I add 360 to that, I get to 30. And so now we're looking for the sine at 30. So we go to 30 degrees, pick out the y value, and there it is, a positive 1/2. So the sine for negative 330 degrees is 1/2. Okay, ultimately, again, the goal is going to be for us to kind of have this happening in our head, so we can figure out where these angles are, what these exact values are for sine and cosine without having to touch a calculator. Although, as I mentioned, throughout a couple of these here, the calculator could be used to verify your work. So let me just show you, like, let's say I wasn't sure about this one here. I said that the sine of 60 was radical 3 over 2. Well, if I put, let me make sure my calculator's in degree mode. In my calculator, if I type in and ask it to tell me what is the sine of 60, it's going to give me a decimal. Well, according to what I have in my paper, that decimal, or radical 3 over 2, should be that decimal, that same decimal amount. So let me just go ahead and confirm by putting radical 3 divided by 2 there. Oops, forgot to divide. Oh my good gracious, what am I doing? 2. There we go. So now I can see the sine of 60, which I said was equal to radical 3 over 2. The calculator verifies that both those do in fact have the same decimal value. So even though the calculator won't give you those exact values, the unit circle will, we can still use the calculator to verify. Okay? So a lot of information. Don't freak out about having to memorize it yet. Just do your best to wrap your brain around how we built it, what we used to build it, and how we can use it. And then as we move forward, we'll get practice in. Hopefully this will sink in a little bit better. Okay? So hopefully got enough to do your practice. If you have any questions, by all means, reach out. Until next time, take care.